Lesson 4.3, 1 and 2-step equations. Solving 1 and 2-step equations requires doing the opposite operations in a specific order. Basically, we undo PEMDAS. We've done 1-step equations in the previous module, and they included problems like these. The first thing we needed to do was identify the operation, and then we needed to perform the opposite operation. Two-step equations are like one-step equations, but there's an extra step. The variable x has had two things done to it instead of just one thing, and we have to undo both of them. So, for example, if we have 3x plus 5, x was multiplied by 3, and then 5 was added to it. So to undo that, we have to take the 5 away and the multiplication of 3. 2x minus 1 means that x had been multiplied by 2 and then had 1 subtracted from it. X divided by 7 plus 9. X was divided by 7 and then had 9 added to it. 2/3 x. There's two ways to look at this. Either x was multiplied by 2/3, or x was multiplied by 2 and divided by 3. They mean the same thing, but for some people, multiplying by 2/3 or multiplying by 2 and dividing by 3, one or the other will be an easier concept. So now we want to solve the equations. So we do the order of operations backwards. So the first thing we'll need to do is add or subtract to undo what was already there. The reason we add or subtract first, because in the order of operations, adding and subtracting is last. So when we're undoing, we move backwards. So we'll add or subtract first. So first we're going to subtract 5. That will give us 3x is equal to 12. Then the next step is to multiply or divide to undo what was already there. This is multiplication, so to undo the multiplication, we're going to need to, we'll divide both sides by 3, and we'll get that x is equal to 4. For our next example, the first step is to add or subtract to undo what was already there. So we'll subtract 9 from both sides. That will give us x over 7 is equal to 22. Then we need to undo this division. This is x divided by 7, so the opposite operation is to multiply both sides by 7. Multiplying both sides by 7 will give us that x is equal to 154. I forgot to bring that up. Now this example, 2/3 x equals 14, that can be solved in two ways. We can do it as a one-step problem or as a two-step problem. As a one-step problem, we're going to multiply both sides by the reciprocal. So I'm going to multiply by 3/2 and 3/2. These 3's will cancel. These 2's will cancel, and that will leave me with an x. 14 times 3/2 can be dealt with in two ways. We can put 14 over 1 and multiply 14 by 3 and 1 by 2 and then reduce the fraction. Or if this denominator will divide into the whole number, we can do that first. And then we take 7 times 3, and that gives us 21. To work it as a two-step problem, the first thing we want to do is multiply both sides by the denominator. So we multiply both sides by 3. And that leaves us with 2x is equal to 42. Then we divide both sides by the leftover numerator. And that will give us that x is equal to 21. As you can see, we get the same answer either way. It's just a matter of preference. If you don't mind working with fractions, multiplying by the reciprocal gives you the result in only one step. If fractions are bothersome for you, multiplying by the denominator first turns this into a two-step problem, but eliminates the need to work with the fractions. And sometimes the fraction can cause a two-step problem to act like a three-step problem. So for this example, we have 4/5 x plus 7 equals 13. To do it as a two-step problem, we subtract both sides by 7. And we get 4/5 x is equal to 6. Oh, sorry, I'm doing it as a three-step problem first. Multiply both sides by the denominator, which will leave us with 4x is equal to 30. And then divide both sides by the numerator. 30 and 4 don't divide evenly, so I can reduce that fraction to 15/2, or I can give the decimal answer of 7.5. If I want to do it as a two-step problem, I'm still going to subtract first. Then I multiply both sides by the reciprocal. That will give me x is equal to 30 over 4, which can be reduced to 15/2, or you can give the decimal answer. The next type of equation involves having variables on both sides. For example, 8x minus 4 is equal to 5x minus 14. Now to solve this, we need to get all of the variables to one side of the equation. So we're going to have to move some things around. But first we need to check to see if each side of the equation can be simplified. Are there any like terms that we can combine on either side? In this case, no, they're both simplified. Step 2 is to relocate the variables to the same side of the equation. So in this case, I'm going to subtract 5x from both sides, which will give me 3x minus 4 is equal to negative 14. Then we needed to combine those variables to simplify. Step 4 is to relocate the constant to the other side of the equal sign. So I'm going to add 4 to both sides. And then we combine those constants to simplify. And then we multiply or divide to solve for the variable. In this case, it doesn't divide evenly, so we will leave it as a fraction. Here are some more examples of this type of equation. We can either move the 9x or the 3x. Depends on whether you prefer your variable to be positive or negative, or if you prefer your variables to always be on the right or the left. I tend to like to put mine on the left, so I'm going to go ahead and subtract 9x from both sides. That'll give me negative 6x plus 10 is equal to negative 32. Then I will subtract 10 from both sides, and that will give me negative 6x is equal to negative 42. Then I will divide both sides by negative 6 to give me that x is equal to 7. What I would like you to do right now is to go ahead and pause the video, work out these 3 additional problems on your own. When you've finished, turn the video back on and we'll go over the steps and you can see how you did. Okay, now that you've had a chance to work these out, let's look at the answers that I got and compare them to the answers that you got. Were you able to get to a positive 1/2? If not, review my steps and compare them to yours and see if you can find the error. For C, x equals 3, and for D, x equals 0. Actually, on this step, anytime you have any number times a variable equals the 0, the variable has to be the 0. So you can actually skip the dividing by 2. Okay, now we need to solve some multi-step equations. The first thing we want to do is distribute. I'm going to multiply 2 times 3 and 2 times negative 4, 3 times 6, and 3 times negative x. That'll give me 6x minus 8 plus 5 is equal to 18 minus 3x plus 2x. The next thing to do is to collect like terms on each side of the equation. On the left, I have a negative 8 and a 5 that can be combined. On the right, I have a negative 3x and a 2x that can be combined. Now we move our variables, so I will add x to both sides. Then we add, so I get 7x is equal to 21. Then I multiply or divide, so in this case I'm dividing, and I get x is equal to 3. Here are some more examples. I'm going to work out A and C, and I'll have you work out B and D. First, I distribute the 8. Collect like terms on each side. Move my variables all to the same side. Add 27 to both sides. Divide by 27. And since 27 does not go into 30, but both will divide by 3, I get 10 over 9. The reason I wanted to do C is due to these negatives. Now remember, when you distribute with a negative, you have to multiply by the negative number. So it's negative 5 times 4x and negative 5 times negative 2. So I'll get negative 20x plus 10. And then I do negative 2 times 3 and negative 2 times 6x to get negative 6 minus 12x. Now I'll move my variables all to the same side. And I'll have negative 8x plus 10 is equal to negative 6. Subtract 10 from both sides, and I'll have negative 8x is equal to negative 16. And then divide by negative 8 to get that x is equal to positive 2. Now why don't you pause the video and work B and D, and then when you're finished, start the video back up and compare. So check your answers. If you did not get negative 3/7, go through and see if you can find your mistake. I wanted to point out, when the negative is in the denominator, we never leave a negative in the denominator. We bring it out front or up top. And then I also wanted to point out on D, I ended up with negative x is equal to negative 10. When I get a negative variable, I change both signs because I want to know what the positive variable's answer is. Okay, we have equations in which variables with no exponent only have one answer for the most part, but sometimes we can have either no solutions or multiple solutions. So for example, if I have this equation, okay, I'm going to show two ways to solve it. First, I'm going to distribute the 3, so I'll get 3x plus 12 is equal to 3x plus 12, and then I will subtract 3x from both sides, and I'll get 12 is equal to 12. Solving this another way, I can distribute the 3x, and I get 3x plus 12 is equal to 3x plus 12. And perhaps I decided to subtract 12 first, and I get 3x is equal to 3x. In both cases, we get a true statement. 12 is equal to 12. 3x is equal to 3x. If we take it further, we will get 0 is equal to 0, also true. And when we solve an equation and get a true statement, but we don't know what the value of x is, so we don't have x equals some number, then our answer is always infinite solutions. So you can say all real numbers. You can use the bold R for real. You can write all solutions, things to this nature. You can plug in any value for x and it will be true. In another scenario, we'll distribute our 2, and I get 8x plus 3 is equal to 8x minus 4. And if I move my 8x first, I get 3 is equal to negative 4. Or trying to solve it another way, if I subtract 3 first, I get 8x is equal to 8x minus 7, and then I subtract 8x from both sides, and I get 0 is equal to negative 7. And in both of these methods, I got false statement. 3 is not equal to negative 4. 0 is not equal to negative 7. And when that happens, we have no solutions. So you can either say no solutions. You can write DNE, which is math shorthand for does not exist, or you can use the symbol for the empty set. This also means no solutions. Any value that we plug in for x will give us a false statement. There is no number that will work. So combining everything we've learned so far, equations can have one solution, no solutions, or all solutions. One solution gives us the following results: x equals some number. No solution will give us the result that one number equals some other number, and it will always be false. All solutions will give us the result that one number equals the same number. It will always be true. Okay. Solving equations with fractions. We can clear the fractions so that you don't have to do them. First, you determine the common denominator. Then you multiply everything in the equation by that number. And what that does is it eliminates the fractions. And then we solve as usual. So looking at our first example, I have a 6 and a 4. My common denominator is going to be 12. So I am going to multiply every single term in this equation by 12. So 12 times 5 plus 12 times x over 6 equals 12 times 3 plus 2x over 4. Once you've done that, 12 times 5 is 60. 6 goes into 12 twice. Then I multiply 2 times x to get 2x. 4 goes into 12 3 times, and then I distribute in this 3 to get 9 minus 6x. Now I have an equation with no fractions, and I can solve this in the normal fashion. Add 6x to both sides to get 60 plus 8x is equal to 9. Subtract 60 from both sides to get 8x is equal to negative 51. Divide by 8. And since 51 does not divide by 8, I can leave it as a fractional answer. For my second example, my common denominator is 10, so I will multiply every term by 10. Ten times 3x is 30x. 5 goes into 10 2 times. 2 times 2 is 4. 10 times 5x is 50x. And 2 goes into 10 5 times. 5 times 1 is 5. I can subtract 50x from both sides. And I get negative 20x plus 4 is equal to negative 5. I subtract 4. And I get negative 20x is equal to negative 9. I divide by negative 20, and it does not divide evenly, but the two negatives cancel out, so I get 9/20 as my answer. And you may find that working without the fractions simplifies things.